Hello everyone. In this video, we will solve a numerical problem to calculate work done given the electric field intensity and the charge which is to be moved, the initial position of the charge, final position of the charge, and the path of the charge movement from the initial and final position is provided in the question. We are asked to find the work done in carrying this charge. So let us start with the formula for calculating work done. Work done formula is minus q line integration E vector dot dl vector. And here in this case, the initial position of the charge is B with the coordinates 1, 0, 1 and A with the coordinates is 0.8, 0.6 and 1. So let us first compute this E vector dot dl vector and do the integration to find the work done. So let us consider here in this case, the vector E is this. For rectangular system, we can write dl vector as dx ax cap plus dy ay cap plus dz az cap. Now the vector E is given. We have to take dot product between vector E and dl. So dot product between E vector and dl vector is multiplying x and x direction component, that is y dx, then y component and y direction component of both vectors should be multiplied, which is x dy, then 2 dz. So this has to be integrated now with respect to the corresponding differential elements. So work done is minus charge magnitude is 2 and the integration goes like this: y dx plus x dy plus 2 dz with the limits for x, y and z corresponds to the point B and the final limits for x, y and z corresponds to point A. Now this integration is with respect to x, this integration is with respect to y and this integration is with respect to z. So we can write this integration as 3 line integrations in summation for each variable. So let us write this as minus 2 into integration with respect to x is y dx and the next integration is x dy and the next integration is 2 dz. We have to give the corresponding limits for x, y and z. In this case, x limit is 1 to 0.8. Then here for point B, the x coordinate is 1, y coordinate is 0, z coordinate is 1, which forms the lower limit for the corresponding integration. And the upper limit is 0.8, 0.6, 0.1 for x, y and z. That will form the corresponding upper limit for the integrations. So let us write y limit is 0 to 0.6 and z limit is 1 to 1. We need not integrate this z because lower and upper limit are same. That will make this entire integration to be 0. So we can consider this integration will be 0 because the lower and upper limits are same. So this can be made 0. We have to now perform the integration for x and y. But before doing that, we should take care of one more thing here. Here, y variable is there, but integration is with respect to x. Similarly, here x variable is there, but integration is with respect to y. We should write y in terms of x and this x in terms of y. Because this is integration for x, we have to make use of the equation of the path. This is the equation of the path specified. We can make use of this and write y in terms of x and x in terms of y. So we can write that x square plus y square equals to 1. So if I try to write y in terms of x, I will be getting y square is 1 minus x square and thereby y is under root 1 minus x square. So this has to be replaced over here. And similarly, I can write x in terms of y. So that can be written as x square can be written as 1 minus y square and x will be under root 1 minus y square. So these are the substitutions for variables y and x for performing the integration. So let us write that here. Minus 2 into integration. Instead of y, it is 1 minus x square dx, being the limit for x from 1 to 0.8. Then x should be written in terms of y, which is under root 1 minus y square dy, with the y limit being 0 to 0.6. And the last integration is 0 because the lower and upper limits both are same. So now this can be performed by taking the formula if you know. Otherwise, we can make use of the calculator and perform the integration. You should also know the calculator should be used in the radian mode. So I'm changing the calculator to radian mode. We have to type the expressions for the integration. All the variables should be typed in terms of x. So for the first integration, I will type the entire thing here. So minus 2 into the first integration is under root 1 minus alpha x square. So this is the first one. The lower limit is 1 and the upper limit is 0.8. Then we have to type the second integration. The second integration variable is y, but still we should type in terms of x because we have all the functions in terms of x. So we should type in terms of x. That also will become under root 1 minus alphabet x square. The lower limit here for this case is 0 and the upper limit here it is 0.6. So this can be calculated, which will give the answer as minus 0.96. So minus 0.96 is the answer for work done. So work done can be computed as minus 0.96 joules. Now, we will be doing this problem in a different way to understand why the path is specified here. If the path is not specified, then what should be done in this case? If the equation of the path is not specified, then from the points B and A, how we can get to the path equation for a straight line joining B to A. We will be doing that one more time, repeating this, and we will find the work done. We already have discussed in the theory that work done is irrespective of the path chosen if the initial and the final points are same. If it can be taken through a straight line or a curved line, it can be through a straight line or through this curved arc specified as per the equation given. So this arc given by this equation is x square plus y square equal to 1, which is an arc of the circle. This is the equation of the circle. The work done remains same even if it is taken through this arc or taken through the straight line joining points B to A. So we are going to repeat the problem, taking the equation of straight line and compute the work done. Thereby, we can prove the work done is same irrespective of the path. So this will be required if the path equation is not given. We can compute the equation of the straight line and proceed with the problem. For that purpose, I'll repeat this problem again and then show how to compute the equation of straight line and solve the problem in the second way. Now, let us proceed this problem. Without considering this given path, we are going to assume the straight line as the path from B to A. From B to A, let us consider the straight line. We are going to find the equation of straight line. So the straight line equation formula, if you have x1, y1, z1 and x2, y2, z2. So we can find equation of straight line as x minus x1 by x2 minus x1 equals y minus y1 by y2 minus y1 equals z minus z1 by z2 minus z1. So we can make use of this equation of straight line from point B to A and find the equation. Instead of this path, we can make use of the straight line equation and solve for the numerical problem. So let us substitute the values and get the equation, which is going to be, if I take these two, I'll get the equation for x and y relation. I can make use of these two to get the relation between x and z. I can make use of these two to get the relation between y and z. So let us do for x and y relation first, because here in this z is 1, because you can consider the coordinate of B and A has both z value 1. So in that case, z is constant. So we can ignore this. We can make use of only these two relations for x and y and compute the expression or the equation of the straight line. So let us write here x minus x1 is 1, 0, 1. I'll write the coordinates also. So x minus 1 divided by 0.8 minus 1 equals y minus 0 divided by 0.6 minus 0. So this is going to give the equation x by minus 0.2 equals y by 0.6. Or I can write this as, this can be written, this is 1 times means this is 3 times. So I can write x equals to minus y by 3 this is a small mistake. X minus 1, I should have written x minus 1 equals minus y by 3, and thereby x will be equal to 1 minus y by 3. So instead of x, we can write 1 minus y by 3. And similarly, if I want to write in terms of y, so I can write y equals 3 times minus x minus 1. So we can replace x as 1 minus y by 3 and y as minus 3 into x minus 1 to perform the integration. So let me write the formula for work done, which is minus q line integration E dot dl from point B to point A. So the charge q is minus 2, and the integration I can repeat because we have E dot dl, which is same in this case. That is y dx plus x dy. Let me confirm it. Y dx plus x dy plus 2 dz. So the integrations should be done for x, y, and z. X limit is 1 to 0.8. Y limit is 0 to 0.6. And here z limit is 1 to 1. Since z limit is same for upper and lower cases, this will be 0. Now instead of y, I should be writing this expression, and instead of x, I should be writing this expression to perform the integration. This also can be performed using calculator directly. If you are comfortable doing your own, you can do it. Otherwise, you can make use of calculator to solve this integration and get the answer. The second term is going to be 1 minus y by 3 dy 0 to 0.6. So let me take the calculator in this case and type this integral expression and try to get the same answer. We'll verify whether we are getting the same answer. So the calculator must be in radian mode, and I should type minus 2 times first integration, which is minus 3 into alphabet x minus 1, and the lower limit is 1, upper limit is 0.8. You can do by yourself also without using the calculator. Since these expressions are simpler, you can compute it. For the second expression also, we should convert into the variable x. So I will be making use of the variable x, which is 1 minus x by 3 dx, with the lower limit being 0 and upper limit being 0.6. Thereby, we will get the answer, which is minus 0.96. The same answer which we have got for the previous method also, minus 0.96 joules. So this shows that irrespective of the equation of the path, whether it is a straight line equation or a curved line equation through this circular arc, the work done remains same. We have got the same answer of work done for both the cases. So this shows if the equation of the path is given, how to use, or if the equation of path is not specified, we can compute the equation of the straight line and use the corresponding functions into the integral expressions to perform the integration and get the answer. I hope you have understood this problem. Thanks for watching the video, and you keep practicing such problems by yourselves.